When educators plan lessons or assess student learning, two key frameworks often guide their approach: Bloom's taxonomy and Webb's depth of knowledge (DOK). Bloom's taxonomy, first introduced in 1956 and later revised, organizes cognitive skills into a hierarchy from remembering and understanding to analyzing, evaluating, and creating. It has become a fundamental tool in curriculum development, helping teachers align instructional goals with students' capabilities. On the other hand, Webb's DOK, developed in the late 90s, offers a different lens. Instead of categorizing types of thinking, it focuses on the complexity of thinking required to complete a task, ranging from recall and reproduction to strategic thinking and extended reasoning. Webb's framework provides a more in-depth view of how deeply students must engage with content. Although these two taxonomies serve different purposes, they complement each other in purposeful ways. Bloom's helps teachers design learning objectives, while Webb's ensures that the tasks associated with those objectives require approaches that ranges in their cognitive depth. This video will explore how Webb's frameworks intersects with other taxonomies and how educators can use both Webb's and Bloom's taxonomy to create more meaningful, challenging, and equitable learning experiences that cater for the needs of different learners. Whether you are designing assessments, crafting learning activities, or just aiming to deepen student thinking, understanding the relationship between the taxonomies is key. So what is Webb's taxonomy? Webb's taxonomy, DOK, is a framework used to categorize the complexity of tasks or questions in educational settings. It was developed by Norman Webb, a researcher in education, to help educators assess the depth of understanding required by students in response to tasks and questions. Webb's taxonomy consists of 4 levels, each representing increasing cognitive demands. Starting with recall and reproduction, which is level 1, students are expected to recall or reproduce basic facts, definitions, or procedures. These tasks typically involve direct memorization or simple recall. The second level of Bloom's taxonomy involves applying skills and concepts to solve problems, but with some structure or guidance. It may require students to make decisions or interpret information, but the task is still relatively straightforward. Thus, it is categorized as applying knowledge and skills with basic reasoning. The third level, which is the strategic thinking, requires students to engage in reasoning, planning, and using evidence to solve complex problems. It involves critical thinking, creativity, and the ability to plan and think strategically. The fourth level, which is the extended thinking, involves tasks that require students to synthesize information from multiple sources, make connections across disciplines, and engage in complex problem solving. The tasks are often open-ended and require students to demonstrate high-level analytical and critical thinking skills. Webb's taxonomy is used to align curriculum instruction and assessment, helping educators ensure that students engage with content in a way that promotes higher order thinking and deeper learning. It's particularly useful in developing assessments that go beyond rote memorization, encouraging critical thinking and problem-solving skills. Webb's taxonomy, or Webb's depth of knowledge, DOK, was created, as we mentioned, by Norman Webb, an educational researcher in the late 1990s, to provide a clearer framework for evaluating the cognitive demands of assessments and tasks in the classroom. Webb first introduced the concept in 1997 in a paper titled Criteria for Alignment of Expectations and Assessments in Mathematics and Science Education. This paper was published as part of a larger study conducted for the National Institute for Science Education, NISE. Webb's work aimed to help educators and policymakers better understand how to assess student performance in a way that reflects higher levels of thinking and problem solving, not just memorization. Webb's depth of knowledge has since become an important tool in curriculum development, assessment design, and educational research, widely used across various educational contexts. Let's now try to see the link and connection between Webb's taxonomy and other taxonomies that were developed by other researchers. We will start with Bloom's taxonomy. Bloom's taxonomy, which was developed in the 1950s, categorized the cognitive learning objectives into hierarchy ranging from lower order thinking skills such as remembering to higher order thinking skills such as evaluating and creating. Webb's taxonomy was in part an attempt to refine and expand upon Bloom's framework, focusing more on the depth and complexity of tasks rather than just the hierarchical structure of cognitive skills. Bloom's taxonomy was fundamental in framing the understanding of cognitive levels in education and providing a fundamental base for Webb's, focusing on the depth of knowledge required in tasks. While Bloom's taxonomy focused on cognitive skills and provided a hierarchical view of how skills build upon one another, Webb's taxonomy focused on the depth of cognitive engagement with the material and organizes tasks based on their complexity rather than skill level. Webb's taxonomy and Bloom's taxonomy are both frameworks used to categorize the complexity of learning tasks, but they approach cognitive demands in different ways. Let's try to speak about the similarities and differences between both taxonomies. Starting with the cognitive complexity, both frameworks aim to assess the cognitive complexity of tasks, guiding educators to design lessons and assessments that engage students at higher levels of thinking. The second similarity is focused on the educational purpose. Both Bloom's taxonomy and Webb's taxonomy are used to help educators create assessments and learning activities that go beyond mere memorization, encouraging students to engage in higher order thinking and application. The third similarity is the progression from simpler to more complex. Both of them organize cognitive levels from lower to higher, with Bloom's focusing on a hierarchy of cognitive skills and Webb's focusing on the depth of engagement with content. The last similarity that we can mention here is the usefulness of instructional design. Educators can use both frameworks to align instruction, assessment, and content with cognitive demands, thus ensuring that students engage with the material in a way that fosters deeper understanding. Let's now move to talk about the key differences in application. The first difference is the hierarchical versus non-hierarchical. So if we look at Bloom's taxonomy, it is hierarchical, moving from lower order thinking to higher order thinking. However, Webb's taxonomy is not hierarchical, but focuses on the type of engagement with content. A task can involve different levels of cognitive demands, as referred to Webb's taxonomy. The second difference, which is the usage in assessment. Bloom's taxonomy is often used to classify the cognitive skills required for different types of questions, while Webb's taxonomy is more focused on task complexity, assessing how much cognitive effort and depth of understanding a task requires. The second taxonomy that we're going to look at and compare with Webb's taxonomy is Marzano's taxonomy. Marzano's work on taxonomy and educational frameworks, particularly his research on the new taxonomy of educational objectives in 2001, emphasized the importance of cognitive processes and knowledge domains. Marzano's ideas about categorizing knowledge and cognitive processes influenced Webb's ideas about cognitive complexity. So if we look at it, Marzano and Webb share similar goals of encouraging deeper engagement with content, though Marzano focuses on instructional design while Webb focuses more on the complexity of assessment and task alignment. Webb's taxonomy and Marzano's taxonomy are both frameworks used to understand the cognitive demands of educational tasks, but they have distinct focuses and structures. Let's talk in brief about the similarities between the two taxonomies. If we look through the lens of cognitive complexity, both frameworks aim to measure the cognitive demand of tasks and assessments. They help educators understand how deeply students must engage with content, moving beyond simple recall and fostering higher order thinking skills. The second similarity, which is application in instruction. Both Webb's and Marzano's taxonomies are used in curriculum design and assessment to ensure that students are required to apply a range of thinking skills, not just recall basic facts. The third similarity, which is levels of cognitive demands. Both frameworks recognize that learning tasks can vary in complexity and that students should engage in progressively more challenging and thought-provoking tasks to deepen their understanding. Let's now talk in brief also about the key differences in application. The first difference that we will focus on is depth versus process. Webb's depth of knowledge is more focused on the depth of engagement with the content. considering how deeply students must think about the content in a task. It is typically used for assessing whether tasks align with cognitive complexity, while Marzano's taxonomy is more focused on how students process knowledge and develop cognitive skills as well as how they regulate their learning. So it offers a broader framework for understanding how learning progresses. The second difference is task complexity versus cognitive process. Webb emphasizes task complexity, categorizing tasks by the type of thinking they require. Marzano includes the process involved in learning with a focus on the cognitive steps and the metacognitive abilities that support learning. So, in brief, Webb's taxonomy is primarily about the complexity of tasks and the depth of cognitive engagement required. It is more task focused and provides four levels to describe increasing complexity. Marzano's taxonomy is broader, encompassing both the cognitive processes and the types of knowledge students must develop. It also integrates metacognitive strategies, encouraging students to reflect on their own thinking. Moving forward, we're going to talk in brief about the main national assessment of educational progress, where Webb's taxonomy was heavily influenced by the researchers on how the NAEP aligned its assessment with academic standards. Webb was involved in analyzing the alignment between state content standards and state assessment, which led to his development of the DOK framework. So Webb saw to ensure that assessments not only measured content knowledge but also tested students' ability to analyze, apply, and synthesize that knowledge. Looking at the association, the American Educational Reach, Webb's work was also shaped by broader educational research and the standards of the AERA, which contributed to the way cognitive complexity was studied and conceptualized. Research in the field of educational psychology and measurement, as well as the work of scholars within the association, helped shape the discussions around assessing different levels of thinking and learning in educational setting. Moving forward to talk about the National Institute for Science Education and its alignment with Webb's taxonomy, Webb's 1997 study titled Criteria for Alignment of Expectations and Assessments in Mathematics and Science Education was funded by the National Institute for Science Education. This study was a fundamental moment in the development of Webb's depth of knowledge framework, as it addressed how to measure the depth and complexity of students' understanding in these subject areas. Looking more at the conceptual framework and the theoretical framework of the Webb's DOK, we will shed the light lastly at the National Research Council, which has also played a key role in contributing to the research on cognitive complexity, particularly with their work on science and maths education. The NRC's reports and studies, particularly those regarding the alignment of assessments with instructional goals, help frame discussions around how to improve educational outcomes through more rigorous assessments that align with cognitive expectations. So, in summary, Norman Webb developed his taxonomy in response to the educational challenges and insights from scholars and studies aiming to create a more refined and contextually applicable measure of cognitive complexity in learning opportunities, tasks, and assessment. Let's move now to talk about each one of the four levels related to Webb's taxonomy and try to talk about the key characters, the main examples, the cognitive skills required at each level, and the different content areas, illustrations with little bit of focus on importance and challenge for each one of the four levels. Starting with level one. Level one, which is recall and reproduce, is the first level of Webb's depth of knowledge, and it focuses on tasks that require students to recall or reproduce information they have previously learned. This level is the simplest in terms of cognitive demand, but is essential as the foundation for more complex tasks that require higher order thinking. At level 1, students are asked to remember or retrieve facts, definitions, procedures, or specific details from their prior knowledge. These tasks do not require significant interpretation or critical thinking. Instead, they demand the ability to assess and reproduce information from memory. In Webb's DOK 1, tasks are considered low cognitive demand because they focus on basic foundational recall. These types of questions or tasks serve as the starting point in the process of learning and understanding new material. However, this does not mean that they are unimportant. Mastery of fundamental knowledge is crucial for building a deeper understanding of more complex concepts. Examples of tasks at level 1 will be recall facts, such as asking students questions or assigning tasks which requires them to recall specific pieces of information. The second type is define terms, asking students to recall and define specific terms, definitions, or concepts from memory. Third, recognize basic procedures, where we ask students to recognize or replicate a simple procedure or process they have learned. The fourth type, which is identify facts and details. Here, we ask students to complete tasks that involve identifying specific pieces of factual information, often with no interpretation required. Lastly, simple memorization. Students are asked to complete tasks that require them to simply memorize and recall information without modification or further explanation. The primary cognitive skill involved at this level is the ability to retrieve previously learned facts or information from memory. This can include recalling definitions, formulas, dates, names, or processes. Sometimes recall is replaced by simple recognition, where students are asked to recognize a fact or detail among other choices. This involves identifying correct answers or recognizing patterns without having to generate them independently. Reproduction refers to the ability to reproduce or demonstrate previously learned material inside the classroom. Examples of level 1 tasks might be multiple choice question with factual recall, fill in the blanks, true or false, or short answer, similar to the examples given. Going more in depth to talk about examples for different content areas, such as maths, science, history, or language art, we will see in this slide some of the examples for tasks or questions that are classified as DOK Level 1 according to Webb's taxonomy. Let's talk about the importance of Level 1 tasks. First of all, while Level 1 tasks may seem basic, they form the building blocks for higher level thinking. For example, without knowing key facts or being able to recall basic concepts, students would struggle to apply, analyze, or create with that knowledge in more complex tasks. Second thing, mastery of level 1 skills helps build fluency in subject areas. When students have quick and automatic recall of basic facts, they can focus more attention on higher level tasks that require critical thinking and problem solving. Third point, level 1 tasks are often used to assess students' basic understanding of concepts and content. They ensure that students have acquired the fundamental knowledge necessary before progressing to more advanced skills. The fourth point, level 1 tasks can serve as formative assessments to check whether students have grasped essential concepts or content. Teachers can use these tasks to identify gaps in students' knowledge early on during the delivery of the lesson. What are the challenges and limitations of level 1 tasks? The first one is the limited cognitive engagement. Because level 1 tasks do not require deep thinking or analysis, they primarily assess memory, which may not reflect a student's true understanding of the material or ability to apply knowledge in real-world scenarios. The second limitation is rote learning. Excessive focus on memorization and rote learning at level 1 may limit students' abilities to think critically, problem solve, or engage in creative thinking. The third limitation is the lack of higher order thinking. As students advance in their education, the focus should shift to more complex cognitive skills. Level 1 tasks alone cannot encourage students to develop higher order thinking or the ability to apply their knowledge in unfamiliar situations. Let's think about the classroom. At the beginning of the lesson, the focus will be on rote learning. But As students advance in their classroom session, the focus should shift to more complex cognitive skills, such as analysis, evaluation, and creation. As a conclusion, Level 1, recall and reproduction, is a crucial foundation in Webb's depth of knowledge taxonomy. It is necessary, it is essential, and it focuses on recalling and reproducing facts, definitions, and procedures. While tasks at this level require minimal cognitive effort, they play an essential role in helping students build the necessary foundational knowledge for more complex tasks. Effective teaching should balance the need for level 1 tasks with opportunities for higher order thinking to ensure students develop both fluency and critical thinking skills. Let's move now to level 2, which is skills and concepts. Level 2 skills and concepts is the second level in Webb's depth of knowledge taxonomy. At this level, the cognitive demand shifts from simple recall to tasks that require application and the use of skills or concepts. While tasks at level 1 involve remembering and reproducing facts, level 2 involves tasks that require students to apply these facts in different contexts and demonstrate their understanding of concepts. This level is still considered low to moderate in cognitive demand, but it demands a higher level of engagement with the content compared to level 1. Students must apply what they know in real-world situations or use multiple pieces of information to solve problems, recognize patterns, or make connections. At level 2, students are asked to apply skills and understand concepts in ways that go beyond simple recall. These tasks require students to use previously learned facts and principles in familiar contexts or situations, demonstrating an understanding of relationships between ideas and processes. The tasks involve interpretation, classification, comparison, and simple reasoning, but does not require extensive analysis or the development of original solutions. Let's look at some examples of tasks at level 2. First one, applying procedures or concepts. Tasks that require the application of learned procedures or concepts to solve problems, but these problems are usually familiar and involve known strategies or steps. The second one, which is classifying information. Students might be asked to classify or categorize information based on certain criteria or concepts. The third one, which is summarizing or describing, where students will be asked to summarize or describe a concept or a process they have learned, showing their understanding. The fourth type is focused on tasks that require students to predict outcomes or make inferences based on known information or patterns. The fifth type, where students may be asked to identify relationships between two or more concepts or ideas. Last but not least, following multiple step procedures. Tasks requiring students to use a series of steps to solve a problem or apply a procedure, but the steps and procedures are not overly complex. If we look at level 2 tasks given here, we will clearly see that the cognitive skills required at level 2 are application, interpretation, classification, comparing and contrasting, and reasoning. Let's look at some of the examples of task 2. The first one is also multiple choice question, which we have seen in level 1, but here with application. The second one is short answer question. The third one, problem solving. The fourth one is diagram interpretation. Let's look now at the different content areas in maths, sciences, history, and language arts. As you can see, the examples given here will also require some analysis, but will not go in depth in the application and the interpretation of the concept. Regarding the importance and constraints, why level 2 tasks are important? Number 1, level 2 tasks ensure that students have moved beyond basic recall and are using their knowledge in meaningful ways. It's an essential step in the learning process because students are applying concepts and practicing skills in real-world or practical contexts. Number 2, although level 2 tasks do not require the higher order thinking associated with complex problem solving, they do encourage students to begin using reasoning and logic to think about the material in a more applied way. These tasks help lay the groundwork for more advanced thinking. Number 3, this level provides opportunities for students to reinforce and practice what they have learned. By applying knowledge in new contexts, students strengthen their understanding and become more proficient in using their knowledge and skills. The fourth one, tasks at level 2 allow teachers to assess whether students understand the content and can apply it appropriately. This is often a step toward more complex analysis and application as students need to prove they can use basic concepts before moving on to deeper learning. But what are the challenges and limitations? Number 1, shallow application. While level 2 requires students to apply their knowledge, it often involves routine tasks that are familiar or based on straightforward scenarios. This means that while students are not merely recalling facts, they are still not deeply challenged in terms of thinking or creativity. Number 2, limited depth of engagement. Those tasks do not require students to engage in extended thinking or synthesis. As a result, they may not fully encourage thinking critically or the ability to develop original solutions to complex problems. The third one, which is over-reliance on rote learning. If students have not fully mastered the fundamental knowledge, they may struggle to apply concepts. As a result, level 2 tasks may reinforce a surface level understanding rather than deep conceptual mastery. So as a conclusion, level 2 is an essential stage in the learning process, requiring students to apply knowledge and skills in a new but familiar context. This level moves beyond recall to encourage deeper engagement with content, helping students strengthen their understanding and build a foundation for more complex thinking in higher levels. However, while important tasks at this level are still relatively straightforward and do not involve the deeper analysis and problem solving required at higher levels of Webb's depth of knowledge. As such, level 2 tasks should be balanced with opportunities for more complex cognitive engagement. Let's move now to level 3. Level 3, strategic thinking, is the third level in Webb's depth of knowledge DOK taxonomy. At this level, students are required to engage in higher order thinking that involves strategic reasoning, planning, and problem solving. Tasks at level 3 go beyond simple application of skills and require students to think critically, analyze information, and devise strategies to approach complex problems or tasks. This level emphasizes the ability to organize and synthesize knowledge, make decisions, and problems to be solved in ways that involve higher levels of analysis and reasoning. At level 3, students are asked to think strategically to solve problems or make decisions that require careful thought, planning, and reasoning. The tasks require students to make decisions, interpret complex information, and devise approaches to problems or challenges that are not straightforward or routine. Unlike level 2 tasks, which may involve applying known procedures to familiar problems, level 3 tasks involve unfamiliar situations or problems that demand reasoning and problem solving skills. Level 3 tasks might require students to analyze multiple pieces of information, make judgments, and choose appropriate approaches to reach conclusions or solve problems. Students may need to plan, prioritize, or make decisions, and they are often required to reflect on their thinking or justify their reasoning. Examples of tasks are level 3 can be problem solving, justification and explanation, planning and decision making, analyzing complex scenarios, comparing and contrasting, synthesis of information. Let's look at some specific examples, which can be case study analysis, research projects, designing a solution, or creating a multimedia presentation. Cognitive skills required at level 3 are reasoning, analysis, justification, decision making, planning and organizing, and reflection. If we look at some examples for specific disciplines, here we have for maths, science, history, and language arts. Let's now move to look at the importance and the limitations of level 3 tasks. First of all, level 3 tasks help develop students' ability to think critically, make informed decisions, and solve complex problems, which are essential skills for both academic and real-world contexts. Secondly, this level requires students to combine and synthesize knowledge from various sources, disciplines, or contexts, which fosters deeper learning and broader perspectives. Third, in the real world, individuals must often analyze complex problems, weigh various factors, and make decisions with significant consequences. So, level 3 tasks simulate this type of thinking and decision making. Fourthly, tasks at level 3 are more engaging and require students to use their knowledge in creative and strategic ways, which can foster greater interest in the subject matter and help students develop a more robust understanding of the content. Let's look at the challenges and limitations. Number one, because level 3 tasks require deep thinking, analysis, and decision making, they can be challenging for students who have not yet mastered the fundamental concepts at levels 1 and 2. Without a solid base of knowledge, students may struggle to approach these tasks effectively. Number two, tasks at this level may require more time and effort to complete, as students must carefully analyze information, reflect on their thinking, and justify their decisions. This can be overwhelming, particularly in time-constrained classroom settings. Number three, need for prior knowledge. To successfully engage with level 3 tasks, students need to have a deep understanding of the content and have developed strong analytical and reasoning skills. If students lack the necessary background knowledge or experience, they may struggle to approach these tasks strategically. As a conclusion, level 3 is a critical phase to foster higher order thinking and problem solving skills. It requires students to think critically, analyze complex problems, and devise strategies for addressing them. These tasks not only deepen students' understanding of the content, but also prepare them for real-world challenges by developing their ability to think strategically, plan effectively, and make informed decisions. While these tasks are cognitively demanding, they are an essential steps in preparing students for academic success and the demands of life beyond the classroom. Let's now move to level 4 in Webb's taxonomy. Level 4 is the highest level in Webb's depth of knowledge taxonomy. This level requires the most complex cognitive processing and involves tasks that demand extended inquiry, synthesis of multiple sources of information, critical analysis, and the ability to develop original solutions or construct new insights. Level 4 tasks require students to engage in higher order thinking over an extended period of time and often involve addressing complex, multi-faced problems that do not have clear or straightforward solutions. At level 4, students are asked to engage in tasks that require sustained and advanced thinking, typically over a longer period of time. These tasks demand that students synthesize information from a variety of sources, create new ideas or theories, and analyze complex problems in ways that require innovative thinking. The key characteristics of level 4 tasks include extended time and effort, synthesis and evaluation, creativity and innovation, complexity and depth. Looking now at examples of tasks at level 4, we will talk about conducting independent research, developing a comprehensive plan or proposal, creating a theoretical model or framework, solving complex real-world problems, collaborative group projects, engaging with complex case studies, and writing a research study or journal article. The cognitive skills required at level 4 are synthesis, evaluation, creativity and innovation, complex problem solving, and critical reflection. Examples of level 4 tasks could be long-term research project, global policy proposal, designing an innovative product, developing a new theory. Let's look now at different content areas, such as maths, science, social studies or history, and language arts. As you can see that all of those given tasks require and demand a very high cognitive ability, which requires students to engage in extended thinking to complete those tasks successfully. Looking now at the importance and constraints, number 1, we will talk about the importance of level 4 tasks. So, level 4 tasks are essential for developing advanced cognitive skills such as critical thinking, synthesis, and creativity. These skills are necessary for students to excel in higher education, the workplace, and real-world problem solving. Number 2, tasks at level 4 require students to engage deeply with content, apply it in new ways, and create original knowledge. This deep learning helps students internalize complex concepts and prepares them for lifelong learning. Thirdly, level 4 tasks mimic the types of challenges students will encounter in their future careers and lives, whether in research, innovation, policymaking, or entrepreneurship. Level 4 tasks develop skills that are essential for tackling complex, ambiguous problems. Lastly, at this level, students are encouraged to generate new ideas, propose original solutions, and think beyond existing boundaries. This fosters innovation, which is key to addressing the challenges of the modern world. What are the main limitations of level 4? Number 1, time consuming. Because level 4 tasks require sustained effort and significant time investment, they can be challenging to implement in a classroom setting with limited time. high cognitive demand. These tasks require students to have strong fundamental knowledge and advanced skills. Without proper scaffolding or prior knowledge, students may find level 4 tasks overwhelming. Lastly, complexity. The complexity of level 4 tasks can make them difficult for students to manage without appropriate guidance, support, and resources. Clear instructions and structured frameworks might be necessary to help students successfully navigate these tasks. So, as a conclusion, level 4 extended thinking represents the highest level of cognitive challenge. Level 4 tasks foster the development of critical thinking, problem solving, creativity, and innovation. Skills that are essential for academic success and for addressing real world challenges. Though cognitively demanding, these tasks provide opportunities for students to demonstrate their deep understanding, apply their learning in novel ways, and prepare for the complexities of life beyond the classroom. Let's now shift gears to talk about Webb's taxonomy in relation to assessment and why is it considered a fundamental key block to get reliable and valid assessments. Webb's taxonomy is critical for creating reliable and valid assessments because it provides a structured framework to evaluate the depth and complexity of student learning and cognitive engagement. By categorizing tasks into different levels of cognitive demand, Webb's taxonomy ensures that assessments align with the learning objectives and the cognitive processes that students are expected to engage with at different stages of their education. Let's look at some of the key ideas for achieving reliable and valid assessments using Webb's taxonomy. Webb's DOK levels ensure that the assessment tasks are closely aligned with the learning objectives, helping to measure what students are truly supposed to learn. For example, in level 1, we measure basic knowledge or skills for ensuring that students can recall fundamental facts or perform simple procedures. While in level 2, we involve applying knowledge to routine or slightly more complex tasks, ensuring that students can apply and understand concepts. In the last level, we require higher order thinking skills to synthesize information or create original solutions. By structuring assessments according to these levels, teachers can ensure they are evaluating a range of cognitive skills and not just testing memorization or surface level knowledge. Ensures comprehensive measurement of cognitive skills. Webb's DOK provides a comprehensive framework that takes into account different levels of student cognition, from basic recall to complex synthesis and innovation. This variety helps in measuring fundamental knowledge, application of skills, strategic reasoning and planning, and creativity, critical thinking, and problem solving. This multi-level approach helps to avoid overemphasizing a single type of cognitive skill and ensures that assessments measure a broader range of students' abilities and thinking processes. Validity here refers to the extent to which an assessment measures what it is intended to measure. Webb's DOK helps ensure content validity by ensuring that assessments align with the cognitive complexity of the content being taught. For example, if a learning objective asks students to analyze or evaluate a complex scenario, an assessment that only asks students to recall facts would be invalid. Webb's taxonomy ensures that assessments capture the depth of the objective, preventing shallow assessments that do not reflect the true intent of the learning outcome. Moreover, because the DOK framework is grounded in observable cognitive behaviors, it aids in creating assessments that provide accurate reflections of students' actual learning abilities. Moving forward to talk about enhancing reliability. Reliability in assessments refers to the consistency and accuracy of the results. Webb's taxonomy ensures reliable assessment by providing a clear and consistent framework for categorizing tasks based on their cognitive demand. This clarity allows multiple educators to design and grade assessments with a consistent understanding of what constitutes a task at each DOK level. This consistency also helps reduce ambiguity in scoring. For example, if a task is designed at DOK level 3, both the teacher and student know that it should involve strategic thinking, problem solving, or reasoning, and not just routine application of concepts. This shared understanding results in a more reliable scoring and better comparability between different assessment or different classrooms. Prevents assessment gaps or inaccuracies. Webb's DOK levels can help to prevent assessment gaps where certain cognitive skills are either over or under-emphasized. Without a clear structure, assessments might focus too heavily on simple recall, neglecting higher order thinking that is crucial for students' academic growth. By incorporating all levels of DOK, assessments are more balanced, reflecting a comprehensive range of thinking processes. For instance, an assessment that includes only level 1 tasks would not provide a reliable measure of a student's ability to apply or analyze concepts. On the other hand, focusing exclusively on levels 3 and 4 might not provide insight into whether the student has mastered the fundamental knowledge required to succeed in more complex tasks. How does Webb's taxonomy supports differentiation of learning and instruction? Webb's DOK levels allow educators to differentiate assessments according to the needs of diverse learning. For example, students who need more fundamental practice can be assessed at level 1, ensuring that they have the essential knowledge before moving to more complex tasks, while advanced students can be challenged with level 3 and 4 tasks that require deeper thinking and creativity. This differentiation ensures that assessments are appropriate for the skill levels and developmental stages of all students, improving both reliability and validity. Let's see how Webb's taxonomy provides insights into instructional effectiveness. By using Webb's DOK framework to design assessments, educators can gather valuable data on how well their instruction aligns with the cognitive demands of the curriculum. If students consistently struggle with tasks at levels 3 and 4, it could signal that further instructional support is needed in developing higher order thinking skills. Conversely, if students are excelling at level 3 and 4 tasks, it may indicate that instruction has successfully fostered strategic thinking and problem-solving skills. This reflective aspect of assessment helps improve the overall validity of the educational program and the reliability of assessment over time. Let's move now to talk about fairness and inclusivity. Since Webb's DOK requires different levels of cognitive engagement, it encourages the creation of tasks that cater to a wide range of thinking styles, helping to level the playing field for all students. By varying the DOK levels of tasks, educators can assess students' abilities in helping them in different contexts, whether recalling facts, applying concepts, thinking strategically, or engaging in extended problem solving, thus providing a more inclusive and fair measure of their abilities. Lastly, we will talk about how this taxonomy helps foster critical thinking and problem solving. Webb's DOK encourages the creation of assessments that require students to engage deeply with content, encouraging critical thinking, problem solving, and creativity. Level 3 and 4 tasks require students to think strategically and extend their understanding to the material, which not only improves the validity of assessments but also prepares students for real world challenges that demand these higher order skills. So, in conclusion, Webb's depth of knowledge taxonomy is essential for creating reliable and valid assessments because it aligns assessment with learning objectives and cognitive demands. It measures a range of cognitive skills from basic to complex. It promotes validity by ensuring tasks reflect the depth of content and cognitive processes. It enhances reliability by providing clear and consistent criteria for task design and evaluation. It prevents assessment gaps and inaccuracies, ensuring comprehensive measurement, and it supports differentiation, providing assessments tailored to diverse learners. In wrapping up, it's clear that Webb's depth of knowledge taxonomy allows the teachers to engage students in a variety of learning opportunities which have both the depth and complexity needed to develop their critical thinking and problem solving skills. So ultimately, the goal of using Webb's taxonomy is to make sure that students will move through the concepts starting from the simple task, moving into the more complex extended thinking task. Thanks for joining us on this exploration of Webb's taxonomy. Stay tuned and check the channel every week on Thursday to see the new uploaded professional development session recorded about the most important theories and concepts which are shaping the world of educators to promote excellence despite the curriculum provided or the age group or the context of where the educational institution is operating.